Alright, this is problem number 3 from section or from homework set 10.3. It says 8 runners were convinced that the average difference of their individual times for running a mile versus race walking 1 mile is at most 2 minutes. Below are the times. Do you agree that the average difference is at most 2 minutes? Conduct a hypothesis test. So we have, let's call this population 1 and population 2. They're paired samples. So this one person, person A, let's say, this person's running time is 5.1 minutes and the race walking time is 7.4. And so what we want to do is we want to take a look at their maybe we'll call this their running time and their race walking time. So the idea is that we would just subtract these two things and compare it to something else. But notice that all these values over here are larger than these values over here. So instead of doing this subtraction over here, let's call it subtraction of mu sub 2 minus mu sub 1. And so this is saying that, do you agree that the average difference is at most 2 minutes? At most, the phrase at most refers to going up to and also equal to. So when they say at most 2 minutes, it could be 1 minute or 1.5 minutes or 2 minutes exactly, but it can't be more than that. So all the values that are equivalent here would be less than or equal to the number 2. So if we refer to this as your mu sub d, then we have that relationship between mu sub d and the number 2. So we have at most, remember at most is less than or equal to, mu sub d is at most equal to 2. The difference between these two things is at most 2. And in this case we're considering mu sub 2 minus mu sub 1 as a difference, just so we're dealing with positive numbers. So if this is our setup, then this, because it contains a condition of equality, it includes equaling 2, then this will have to be your null hypothesis. So your alternative would be the opposite. So it looks like our null hypothesis would be mu sub d is less than or equal to 2, and so our corresponding alternative hypothesis would be the opposite of less than or equal to, which is greater than. So that would be this one right here. And then so this is the mu sub d. Now if we were to take this sample and find differences and find the average, we get x bar sub d. So x bar sub d would be for the sample. And what they're asking here is, what does that represent? It's the average difference of the running times. So running between 1 mile and walking. So it would be the average difference of times for running 1 mile versus walking 1 mile. And again, when they talk about difference, the order doesn't matter, so it's important for us to know that the order does matter in this case, that we have mu sub 2 first and then mu sub 1 second. I keep stressing that fact because when we come to compute the test statistic and the p-value, etc., that's going to be important for us. Alright, so let's go to our actual problems, and I've inputted those answers already. Here's the mu sub d less than or equal to 2. Here is the mu sub d bigger than 2. That's your alternative hypothesis, and represents the average difference in times. So the next part of the problem is asking for the test statistic, etc. So I tried this one way and it didn't work out for me because I had the mu sub d. I took the difference backwards, and so we're going to attempt it where hopefully it'll be correct this time. So first of all, our distribution is a t distribution because we're using the t. By the way, there's no information about the population standard deviation given here anywhere, so we're going to use a t-test. And so there's 8 of them, so our distribution would be t sub the degrees of freedom, which is 8 minus 1, that's 7. Okay, it's asking us what is our test statistic. So let's go to our calculators and do our subtraction. So we're going to create a list here where we're taking the differences of each of these data points, and like I said, we're going to make it positive by letting L2 go first. So L2 minus L1, and that's going to create us a list of the differences between these two things. And if you want to just eyeball it, 7.4 minus 5.1 is 2.3, and then that goes on for the rest of the list. Now let's go to stat and test, and we're doing the t-test. So the t-test, we have the data all set up for us in L3, so that's a list that we're going to use. Now the mu sub 0, it's usually 0 since we're usually just comparing 2 points or 2 sets of data, but here we're comparing it with respect to 2. They're saying the difference is at most 2, and so it's important that the 2 is there. So our list that our differences are in L3, our frequency is going to be 1, and here's the other important piece of information. We found that our alternative hypothesis is mu sub d is bigger than 2, so bigger than mu sub 0, which is equal to 2 there. Bigger than 2 is our setup. So let's ask it to calculate. And we're going to get information here, like our test statistic being 3.013. Let's see if that works out. 3.01 to 2 decimal places, that'll work. Our p-value is up to 4 decimal places, 0.0097, let's call it 98. And the p-value, this is always going to be the case, so the p-value is going to be an h not as true when so if h not is true, and then we actually found that the difference is not true, so at the opposite of at most is at least, so we should be looking at this one. We should check our answers right now, but let's go on and see if we can keep taking a look at it. Oh, picture. What's cool about this calculator, and for such a small p-value it'll probably be hard to see, but let's see if we can have it pop up. Let's go back to our t-test and enter. And instead of doing the calculate option, let's try the draw option to see what it does for us. This distribution, the t distribution, looks a lot like the normal distribution, although it is not the normal distribution. And if you click draw, it gives you your 2 important values, the test statistic and the p-value. And what you can't see very well over here is that this little bit is shaded. So past, what's our test statistic again? 3.013. So this is the 0.1, the 0.2, the 0.3, and 3.013 gets shaded over here. So this area that's shaded is actually 0.0098. And so if you were to draw this, you can mark this as this 3.013 and shade in that little area to the right of that. So that's a drawing that's being asked. Honestly, for the homework part of things. I'm generally not going to worry too much about that, but I do expect you to be able to do this on exams, quizzes and exams. Alright, let's take a look at the rest of them. Alpha is 0.05. Now our test statistic, our p-value is 0.0098. That's way less than alpha, so we're going to call that a reject the null hypothesis when your p-value is less than alpha. So since p-value is less than alpha, what are our options? We do reject the null hypothesis. And since we rejected the null hypothesis, we can say that there's enough evidence to show that the time is actually greater than. So the less than or equal to was the null hypothesis that we rejected. And so we can probably agree that the time is greater than, and so that must be the other conclusion part. So explain which made you determine, or which helped you decide on your distribution. We didn't use a standard normal distribution. We use a t-distribution because we're looking at matched pairs. So when we have independent and the population is not known, we're going to use a 2-samp t-test. So there's a 2-samp t-test with a different set of rules and parameters, and you'll have different degrees of freedom for that. But for matched pairs, we're going to use a t-distribution. Okay, let's submit answers and check our work to make sure it's all correct. So let's run it backwards. Check, 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 check. More importantly, I wanted to take a look at the test statistic and the p-values, and we got 3.01 and 0.0098, so that looks looking okay. Alright, so that's a quick rundown. I hope this isn't too late to get you going with your homework set.